On New Year's Day, 1995, a laser sensor bolted to the underside of a North Sea oil platform recorded something that should not have existed. A wall of water rose 84 feet from trough to crest, roughly the height of an 8-story building, in under 20 seconds. For over 100 years, the math had said this was impossible. Not unlikely. Impossible. Ships were built, sailors were trained, and entire fleets crossed the ocean on the assumption that a wave this size could only happen once every 10,000 years. So, when the numbers came back from that platform, the engineers who saw them assumed their equipment was broken. It wasn't. The ocean had just broken the math instead. And once you understand how, you'll never look at the sea the same way again. For centuries, sailors came back to port, with stories of towering walls of water that rose out of nowhere and swallowed ships whole. In 1826, a French naval officer named Jules Dumont d'Urville reported seeing a wave 108 feet tall in the Indian Ocean. His own peers ridiculed him for it. Science had a model, and the model didn't allow for monsters. That model was called the Gaussian Sea, and it treated wave heights the way statisticians treat human height. Most people cluster around 5'7". Every once in a while you'll meet someone who's 7 feet tall, but finding an 80-foot wave in a 30-foot sea would be like walking down the street and running into someone who's 60 feet tall. The math said it couldn't happen, so for 100 years, science quietly decided the sailors were lying. But the ocean doesn't care what the math says. On the 12th of December 1978, a German cargo ship called the MS München vanished in a North Atlantic storm. It was 7 feet long. State-of-the-art, considered practically unsinkable. It sent out a string of frantic, garbled distress calls, then went silent, along with all 28 crew members. Search teams found almost nothing. Just a single, unlaunched lifeboat, still attached to steel mounting pins that had been bent backward with tremendous force. Those pins were 66 feet above the waterline. The only thing on Earth that could bend steel that high in the air is a solid wall of water striking from above. The maritime court investigating the wreck could only conclude that an unusual event had sunk the ship. Because officially, a wave that size still couldn't exist. Here's what should stop you. 17 years later, the ocean stopped hiding. On that same New Year's Day in 1995, the Draupner platform in the North Sea was riding out a fierce but ordinary storm. The surrounding waves were averaging 39 feet, rough, but nothing unusual for the season. Workers had already gone inside. Then, at exactly 3:24 in the afternoon, a downward-facing laser sensor recorded a single wave spiking to 6 meters, 84 feet. More than double the height of everything around it. Engineers at the Norwegian Geotechnical Institute pulled the data and figured the sensor had short-circuited, but the reading was clean. The wave had struck the platform's deck hard enough to leave physical damage, high above where any normal wave should ever reach. The data matched the damage. The impossible wave was real. And here's the part that should really unsettle you. It wasn't a one-time fluke. Just 2 months later, a different platform called Draugen got a storm warning for something the crew nicknamed Rasmus, the old sailor's word for the biggest, deadliest kind of wave. The platform manager moved the entire crew into the gymnasium and pressed them against the inner walls. Moments later, the wave hit the concrete structure so hard it triggered what's called a ringing event, shaking the whole platform for over a minute straight. It survived. But the message was clear. These waves weren't rare exceptions. They were out there constantly, and humans had simply never had the instruments to catch one in the act. So, if the math was wrong, what was actually happening out there? That question took 24 years to answer. In 2019, researchers from Oxford and Edinburgh tried to recreate the Draupner wave inside a massive circular wave pool with 168 individual wave machines. At first, they pushed wave energy in a straight line, the way every wave tank had for decades. It didn't work. The waves just broke and collapsed before they got anywhere close to rogue size. Then they tried something different. They sent two smaller wave groups crossing each other at a very specific angle, exactly 120 degrees. And at that angle, something strange happened. The normal physics that make waves break down simply stopped applying. Instead of colliding and collapsing, the waves stacked directly on top of one another, focusing their energy into a single towering spire of water. It's a bit like a crowd leaving a stadium through a wide open field instead of a narrow hallway. Normally there's room to spread out. No pileup, no crush. But cross two crowds at the right angle, and suddenly they funnel into each other anyway. When the researchers looked at the wave they'd built in the tank, they realized it looked almost identical to a famous Japanese woodblock print from the 1830 seconds. Hokusai's The Great Wave off Kanagawa. An artist had apparently captured the physics of a rogue wave over 150 years before scientists believed they existed. So the mystery was solved. Rogue waves aren't freak accidents. They are a real and repeatable feature of how the ocean moves. And that answer matters more than it first seems. Between 1969 and 1994 alone, at least 22 large cargo ships and over 500 lives were lost to waves that were probably rogue and quietly written off as bad weather. Every ship built before 1995 was designed using math that underestimated how violent the ocean could actually get. And right now, thousands of new offshore wind turbines are being installed in deep water, using foundations sitting directly in the path of physics we're still only beginning to understand. We can split atoms and map the human genome, and for 100 years, we still told sailors that the monsters they saw with their own eyes weren't real. So here's the question worth sitting with. If the ocean has been hiding something this big in plain sight for a century, what else out there are we still confidently calling impossible? Somewhere in the North Sea, on an ordinary stormy afternoon, that question is still rising out of the water.